Hey guys, Mr. T here. This is another video on the sine rule this time. So the sine rule connects the side length of any triangle with the sines of its angles as opposed to cosine. In the previous video, the sine rule can be summarized as below. So sine of the angle capital A is equal to, over A is equal to sine of the angle B over the length of side B, which is also equal to sine of the angles capital C over the length of side C. So these are referring to an angle of interest, and this is the side opposite to that angle. Because of the statement of the sine rule in this method, in this direction, it also fits that it would be the same if flipped over. So just be aware of that. So these are the different ways of presenting the sine rule, and the triangle of interest has sides of length A, B, and C in lowercase, and the angle opposite to those sides are capital A, B, and C. So the sine rule can be used to find sides and angles when two angles and one side are known, or two sides and a non-included angle are known. Non-included angle being an angle is not between the two sides. So let's see how you would use the sine rule when finding sides. In the form given, you can use the sine rule to find side lengths. So this is our example here: non-right angle triangle. We know two angles and a side. So you have been told that the sine rule can be used to find sides and angles when two angles and one side are known. So there we go. Find the length of AC correct to two decimal places. So according to the sine rule, sine of the angle, so we're going to treat 39 degrees as capital A, sine of 39 degrees, over its opposite side, 12, is going to be equal to sine of the angle 58 degrees over the side length, which is what we're trying to find, which is AC. Okay, so let's do some algebraic rearrangement. Cross multiply. So times that by that, times that by that. So multiplying both sides, you would get AC sine 39 degrees is equal to 12 sine 58 degrees. Time to whip out your calculator. We can work out what the right hand side is. AC sine 39 degrees is equal to, so bear with me, getting the calculator. You need to make sure that your calculator is set to degrees mode. So press mode, ensure that radian is not highlighted and degrees is highlighted. So I've done that now. So I can go sine of 58, then multiply that by 12, gives me approximately 10.1766 to 4dp. So I've rounded here. To find what AC is, I need to divide by both sides by sine 39. So divide that by sine of 39. That comes to 16.1707 to 4dp. And the question's asking for it to two decimal places, therefore AC is 16.17, and we're working in centimeters, to two decimal places long. Okay, so that is an example of using the sine rule to find. You could have worked it out with the angle and the sides flipped, so the reciprocals of this, it doesn't matter as long as you are consistent. Okay, so that is finding side lengths using the sine rule. Now, the next way of using the sine rule is to find angles, and we need to worry about the ambiguous case. This is not something in your current textbook. In the given form, the sine rule can also be used to find angles without any significant rearrangement. So unlike cosine rule, where I gave you the angle form of the formula, You don't really need to do that here. The given form is fine. But when finding angles with a sine rule, you've got a problem because there's often two possible answers. That's known as the ambiguous case. The two possible answers are the angle found as normal. So if you were just using the formula as normal, you'll find an angle using the inverse sine. And that's one of the possible answers. But you also, as a weakness of the sine rule, have the possible answer of 180 take the angle found. So we can't just be accepting of two answers. When you use the sine rule and you find angles, you need to check if both answers are possible, or if you can reject one. And this is easy to do, you just need to be aware of it. You need to ensure the angles in the triangle do not exceed 180 degrees. Why? Because the angles in a triangle always add up to 180 degrees. So if you find that you have two answers, and both of them will end up with a triangle that is possible, that's going to have less than 180 degrees for all the angles added up together, then you're going to have to accept both answers. But if you find that your two answers and one of them completely doesn't work because the angles don't add up to 180 degrees, it adds up to more, then you can reject that possibility. So let's see how this works. Find the measure of angle L in triangle KLM, given that angle LKM measures 56 degrees, LM is 16.8 meters, KM is 13.5. So we're trying to find this angle L, so sine of L over the opposite side, 13.5, is going to be equal sine of 56 degrees over 16.8. Now, because the unknown is this, we don't need to cross multiply, we just need to multiply both sides by 13.5 to get sine L by itself. So timesing both sides by 13.5, you're going to get 13.5 written as a fraction is over 1 times by sine 56 degrees over 16.8. Sine L is therefore 13.5 times by sine 56 degrees over 16.8, because when you're multiplying fractions at the top line times by the top, bottom times by the bottom. So now we can work that out in the calculator. Find sine of 56, times it by 13.5, divided by 16.8. So sine of L is approximately equal to 0.6662 to 4 decimal points, rounded there. So now L is going to be inverse sine of that. So in the calculator, do that. So L is going to be approximately 41.7738 to 4 dp. But I've told you and I've warned you of the ambiguous case, so it can either be this angle that you found as normal or 180 minus 41.7738, which is 138.2262 degrees to 4 decimal points. So we're talking angles here, so I need to do the degree sign. So we've got two possible answers right now because we have used a sine rule and we're aware of the ambiguous case. However, 41.7738 plus the other angle we know, because we're saying L is possibly 41.7738 plus 56 degrees, is currently equal to is 97.7738 degrees. So that leaves possible angle for the remaining angle at M, but 138.2262, which is the other possible answer, add the other known angle in the triangle, which is 56. What you'll notice if you add those together is that that's greater than 180 degrees. So this possibility, because of the sine rule, this is a possibility, but obviously it's not, because we can't have an angle that big adding 56 here and then not leaving any more possible angle to add up to 180 degrees in the triangle, which is impossible. So angle L being 138.2262 degrees is rejected. So therefore angle L is going to be this alternative here, 41.7738 degrees to 4 decimal places. Alright, so that is an example of using the sine rule to find angles and how we reject one of the possibilities in the ambiguous case. Hopefully that helps you out, and I'll see you in the next video.